In the last segment, we were talking about percent volume by volume, and you would use this unit when your solute is in a volume unit and your solution is in a volume unit. The most prevalent unit, however, is percent mass by volume, and you would use that when your solute is in a mass unit and your solution is in a volume unit. Such is the case when we use water. As you see on page 19, these two problems that we started on the other segment, but I ran out of memory on my recording device. Glucose is in a mass unit, solution is in a volume unit. Divide the two, multiply by 100%, 4% mass by volume. Casein is protein in milk, grams over milliliters, lends itself to mass by volume. Don't overlook an application, which would be one such as this one that you see. 2 cups of milk or 500 milliliters provides how much protein or casein? 500 milliliters times your percent, by definition, is grams of casein per 100 milliliters. Milliliters cancel, and we get 32 grams of casein. For kicks and giggles, this is about 50% of the amount of protein that's needed for most adults in a day. On the next page, we have this problem. A patient received 2.0 grams of sodium chloride in 8 hours. How many milliliters of physiological saline were delivered? 2.0 grams NaCl, 0.90 grams NaCl per 100 milliliters of saline solution. Grams of sodium chloride cancel, and we end up with 220 milliliters of saline solution to two significant figures. Now those units are great and well and good and all, but in chemistry, we want concentration units based on the mole. And usually and typically that means molarity with the symbol capital M, which is moles of solute per liter of solution. Moles is your clue that we're going to relate this to stoichiometry. Very straightforward application. What is the molarity of 4.50 moles of ammonium hydroxide in 6.78 liters of solution? Moles per liter, 4.50, 6.78. Let's find our calculator. 4.5 divided by 6.78, 0.664 molar. Usually and typically, however, you don't have moles as something that you weigh on a balance. You would have grams. So if you want molarity, you would have to convert grams to mole and put that in the numerator, your milliliter to liter. Okay, so let's put a decimal there. Let's make that 3 significant figures. 115 grams molar mass is going to be 207.2 plus 16.0, 1.0 times 2, 207.2 plus 241.2, double check. Door closing behind me in case you heard that. 241.2, okay. 0.477. That's going to go in the numerator. So 0.477 divided by 0.5 is 0.954. So our molarity is 954 molar. Let's double check. 477 divided by 0.5. 0.954 molar. Okay, how many grams of sodium hydroxide are in 125 milliliters of 4.75 molar solution? The word of in math means to multiply. 125 milliliters multiplied by molarity. Molarity is moles per liter. 4.75 mole per liter. Milliliter and liter, we need a conversion. Liter over 1,000 milliliter. Milliliter cancel, liter cancel, and you can see that you've got moles, which tells you you need to convert to grams, which means right here we need molar mass. 1 mole. Sodium is 23.0, 16.0 for the oxygen, 1.0 for the hydrogen, is 40, I believe. Moles will cancel. 125 times 4.75, 1,000, 40. 125 times 4.75 divided by 1,000 times 40. 23.8. Okay, so let's double check. 125 times 4.75 equals, divided by 1,000 times 40. 23.8. Okay, so you're going to want to try more of these molarity problems. All of these problems, you're going to want to try more of them on Blackboard, or from your book, or from videos, or whatever resources there are for you, because molarity is the prevalent unit in chemistry. The next segment, we'll talk about how you're going to dilute.